Question 7 is technically a two-part problem. There is a part A and a part B, but really part A is just setting us up for part B. So I'm going to do both parts of this problem in the single video. 7a then asks us to solve the homogeneous equation where the second derivative of y plus 9 times y equals 0. And this is probably the easiest question on the whole exam. This is a second order, linear, homogeneous equation with constant coefficients, so all we need to do here is use the characteristic equation. So you could do this from first principles. You could set y equal to e to the rt, and then you get that the second derivative is r squared e to the rt and all that kind of thing. But I think it's much easier to remember that when you're using the characteristic equation, y becomes 1, the derivative of y becomes r, the second derivative of y becomes r squared, and if this were a higher order equation, you continue that pattern. So the characteristic equation in this case then is simply r squared plus 9 times 1, so just r squared plus 9 equals 0. Well, then that would mean that r squared is negative 9. So r is going to be plus or minus the square root of negative 9, which is plus or minus the square root of 9, which is 3, times the square root of negative 1, which is the imaginary number I. So we're getting plus or minus 3i as our roots. They're complex conjugate roots, as they must be. Anytime we get imaginary numbers out of this process, they have to come in pairs, complex conjugate pairs. So therefore, because these are pure imaginary roots, there's not a real part plus an imaginary part, that means that we're only going to get cosine and sine expressions as solutions of this second order equation. So specifically, the general solution then is going to be y equals an arbitrary constant c1 times cosine of 3t plus another arbitrary constant c2 times sine of 3t, and that's all there is to part A, nothing more than that. Part B now asks us to use the method of undetermined coefficients, and our answer to part A to find the general solution of a very similar differential equation, except it's a non-homogeneous equation this time. The left-hand side is the same. It's still the second derivative of y plus 9 times y, but now it's being set equal to the sine of 3t. We needed to solve the corresponding homogeneous equation first, because that information guides us in how we apply the method of undetermined coefficients. This method is all about coming up with basically an educated guess at what a particular solution would look like, because the general solution of a non-homogeneous equation is the sum of the corresponding homogeneous solution, what we call the complementary solution, together with a particular solution. We've already got that complementary solution. That's c1 cosine 3t plus c2 sine of 3t. We need to find the particular solution. So how do we find that particular solution? Well, in the method of undetermined coefficients, we're going to assume that it is based on the non-homogeneous function, in this case sine of 3t, and its derivatives. But we have to be careful, because in this case, that non-homogeneous function sine of 3t, we've just shown, is a solution of the corresponding homogeneous equation. So if we just kind of went into this blindly, we'd say, well, all right, the non-homogeneous function is sine of 3t. The only derivatives we get from that are either multiples of itself or multiples of cosine 3t. So we would guess that the particular solution would be a constant times sine of 3t plus a constant times cosine of 3t, and we would quickly find that when we substitute that into the left-hand side of the differential equation, that everything cancels out. And it has to, because we know that those expressions give us 0. That's what part A demonstrated. So when that happens, and we want to apply the method of undetermined coefficients, what we need to do is we need to treat that non-homogeneous function as if it's actually multiplied by t. So to find a particular solution to the non-homogeneous equation, we're going to consider not the sine of 3t, but rather t times the sine of 3t and its derivatives. So that means that our guess at y sub p is going to be some coefficient called capital A times t times sine of 3t. A derivative of t sine 3t would be t cosine 3t. So that would give us a second potential term in our particular solution. So call it b times t times cosine 3t. Other derivatives we could get from t sine of 3t would be sine of 3t itself. But we can ignore it because we already know that that's a term in the solution of the corresponding homogeneous equation. So we set that aside. And the only other derivative we can get would be cosine 3t, which again is already part of the complementary solution. We don't need to account for it here in the particular solution. If we did, I guess it wouldn't be wrong to do so, but you'd never be able to solve for the coefficient that you give it because those terms are always going to cancel out. Because we already know, again, that they add up to give us 0 when we put them into the differential equation. So in fact, t sine of 3t and t cosine of 3t are the only expressions we get out of the non-homogeneous function and its derivatives if we think of it as being multiplied by t to begin with that aren't solutions of the corresponding homogeneous equation. So there are only two coefficients we need to find, a and b. Well, then we find the first derivative, which is going to be a sine of 3t plus 3at cosine 3t plus b cosine 3t minus 3bt sine of 3t. And then we need the second derivative. So let's see, that's going to be 3a cosine 3t plus, well, another 3a cosine 3t. So I'll actually make that a 6a cosine 3t minus 9a t sine of 3t minus, I'm going to have 3b sine of 3t, and again I'm going to get another one in a moment, so I'll immediately, so that I don't have to scratch out two things on my page here, I'll make that minus 6b sine of 3t, and then the last one I'm going to get here is going to be minus 9bt cosine of 3t. All right, so in order for that to be a particular solution, it has to satisfy the non-homogeneous equation. So now I'm going to take those expressions, I'm going to plug them into the equation. The nice thing is that because dy dt doesn't explicitly show up in this differential equation, I actually don't need that expression for the first derivative of y sub p. I only had to get that so that I could then go on and get the second derivative. So, substituting into the ODE. We're going to get basically everything that I just wrote down on that last line. 6a cosine 3t minus 9at sine of 3t minus 6b sine of 3t minus 9bt cosine 3t plus 9 times y sub p itself, which was at sine of 3t plus bt cosine 3t, and that's all got to add up to give us sine of 3t. So let's see. We've got two expressions that involve t sine of 3t. I've got a minus 9at sine of 3t. That's the second term on the first line. Plus 9 times at sine of 3t. That's the first term on the second line. They cancel out. Likewise, I've got two terms that involve t cosine 3t. The last term on the first line is a minus 9bt cosine 3t. And then to the second line, I got a plus 9 times bt cosine 3t. They cancel out. So the only things I'm going to be left with here, let's see, I've got one term that involves cosine 3t on its own. That's 6a cosine 3t. And I've got one term that involves sine of 3t on its own. That's minus 6b sine of 3t. So that's got to be equal to sine of 3t. And then comparing like coefficients then, well, there is no cosine of 3t term on the right-hand side, so its coefficient is effectively 0. So that tells me that 6a equals 0, which means a is 0. Similarly, I've got to compare the coefficients of the sine of 3t terms. On the left-hand side, that's minus 6b. On the right-hand side, that's just 1. So b, then, is minus 1 over 6. So therefore, a particular solution for this non-homogeneous equation must be, well, at sine of 3t just goes away, becomes 0 because a is 0. So all we've got left is the minus 1 over 6 for b times t times cosine 3t. And so the general solution of this non-homogeneous equation, again, that's going to be the complementary solution plus this particular solution. So that's going to be the c1 cosine 3t plus c2 sine of 3t that we found back in part A minus 1 over 6t cosine of 3t. There we go. We've applied the method of undetermined coefficients successfully to solve this non-homogeneous second-order equation.